All right, in this video, we're going to be talking about the read-only modifier. And the read-only modifier is something that you can attach to a field that's either static or instance that changes how you can access that field during the lifetime of that object. So let me go ahead and fire up a new project. And the concept of read-only is pretty straightforward. Basically, in good or preferred OO design, you don't want to do a lot of mutating of your internal state during the execution of your program. So what I mean is, you want to generally have a sort of guarantee that a particular method doesn't modify a particular value in that class, because that allows you to reason about your code a lot better. Now, C++ handled this with the const modifier, and the const modifier introduced a bunch of headache and was generally quite awful to work around, but the read-only modifier pretty much does that in a different way. It provides the same sort of guarantee, but instead of at a method level, it provides that guarantee at a field level. So let's go ahead and see what a read-only field looks like.
Okay.
So under normal circumstances, we can create a private static int x, and then in the constructor, we can go ahead and assign that x a value. And then, somewhere along the line, we can say, write a method called doStuff that sets x to another value, and so on and so on. And all this code is perfectly valid. Perfectly valid, straightforward, nothing special going on whatsoever. But what if x, what if you are thinking about x in terms of a variable that should be set? It has to be set at some point, but you don't really want it to be modified anywhere outside of a very few particular areas. What if you wanted to say, I have this variable, but I want to guarantee that no other method in this class can edit the value of this variable so that I can better reason about my code, and future maintainers can see that this field does not change throughout the execution of the class. You do that with the read-only modifier. The read-only modifier is only applicable to be attached to fields, and the only thing it really does is it prevents this variable from being set anywhere outside of two places. The two places that a field can be set with the read-only modifier are the field initialization, or the field initializer, and the constructors of the class. So for example, I could do x equals 10 right here, and both this code and this code are perfectly valid. However, in this code, x is no longer valid. This assignment is no longer valid because it says read-only field cannot be used as an assignment target. And now I don't particularly like the error message. It should say read-only field cannot be used as an assignment target outside of a field initializer or constructor.
Mm-hmm.
A few other considerations to take into account with read-only is that, for example, I can go ahead and instantiate another my class within the constructor, and I can do my object.x equals 20. This will not be valid either. Read-only fields cannot be used as an assignment target. Even though I am technically setting this in a constructor of this same type, this code will not compile because I cannot set this variable outside of its own constructor. So read-only applies to every type, reference types and value types, but of course it does not actually guarantee that the reference types themselves are not edited. So for example, if I were to have a private read-only list of ints, and I were to assign it in my constructor, as you should if it's read-only, I can still modify this list outside of the constructor. I can do list.add10. But I can't do list equals new list. So does that differentiation make sense?
Yeah, it does.
So as far as that's pretty much it as far as instance read-only fields are concerned. But read-only fields are also used statically, very commonly in cases where you need to instantiate what you would refer to in the English language as a constant, but which cannot be a constant under the limitations of the C# language. So for example, let's say we have my configuration value, and we give it a constructor that takes an integer and sets it to a field, does something. And then let's say we have a static class called my configuration values. I can go ahead and say public my configuration value value 1 equals new microconfiguration value 1. Public static, sorry.
Yeah.
And you don't want this value to be set anywhere else, but it could be. I mean, there's nothing stopping it from being set anywhere else. And so what you would want to do instinctively is add the const modifier to it. You want to make this value constant. But the problem is like I said, due to the limitations of or of course it can't be static if it's const. Due to the limitations of the C# language, you cannot have a field initializer inside of a const value, and we'll get to the reasons why this is necessary later when we talk about const. But instinctively you might want to do this, but you can't do this. So a better alternative is to do public static read-only microconfiguration value 1 equals new microconfiguration value. The fact that it is a field and is not constant allows you to perform a field initialization, but the fact that it's read-only guarantees that nobody else can edit the value anywhere else in the program. Mm-hmm. Not only that, there is some breaking changes that you need to be aware of where you're considering using const over read-only. And particularly, if I were to have a public const int pi equals 3.14, and that shouldn't be an int, that should be like a double. This is a good example of a constant, but the difference between this and this is subtle but important. This code, whenever the C# compiler sees that you're using pi, this particular pi, and the fact that it is constant, it'll take this value and it'll dump it directly where, instead of having to at runtime compute the value. So it'll literally just replace the word pi with 3.14. And the problem with that is if pi were to ever change, and I were to change this value, and this value was set in a class library that other applications consumed, it would not actually change the value of pi. That's because the C# compiler will actually replace this value. No other reference to pi would exist inside of the compiled application. But because this is read-only, 3.14 is accessed every single time a reference to pi 2 is created. So it adds a little bit of computational overhead, but at the same time, it allows us to make changes to the values without having to recompile any applications that depend on this class library.
Okay.
For that reason, in particular, pi might have not been the best example because it's not going to change from 3.14.
Right,
so that would be a good example of a const. But if you had another value that was not literally a mathematical constant that never changed, if you had a value that wasn't something that never changed, then you definitely want to use read-only instead.
Say like 9.8 as in terms of meters per second for gravity. I mean, that's pretty much always going to be the same if you're on Earth, but if you're maybe coding up a game where you end up on another planet with different gravity values or something like that, then that's something that can be updated.
Right. And you'll want to be able to, like I said, you would want to be able to update that value without having to recompile everybody.
Right.
And so that is where read-only is particularly useful in cases where you might want or you might instinctively go for the const modifier.
Okay.
Other than that, that's really about it.
Okay.
Again, static read-only can also be set in the static constructor. Just like here, we can set it in the field initializers or the static or the instance constructor. Mm-hmm. Static read-only can be set in the static field initializers or the static constructor. But other than that, that's really about it.
Okay, so that will wrap things up for this video. Thank you very much for watching.